Hello, students in Math 1120 Trigonometry. A lot of you have been telling me you're having trouble with the application problem about the cone. So what I'm going to do is give you a few hints on this. The first page, think about it first of all, and then once you get a couple of pages further, once you start kind of analyzing your data, it will actually make a lot of sense what's going on this first page. So what I'm going to do is just show you a couple of things on this. The very first thing I want to have you pay attention to just for a few minutes is what we're really looking for is this angle theta. Think about what's going to happen to this as this angle theta gets smaller and smaller. One of the things that I can show you a little bit on this is this idea. So like for instance, I can take this thing here and use this on the computer to kind of show you. It's actually a little bit misleading. Now, one of the things that I want to focus on here just a minute is really this thing that we call the slant height, and this thing right here is called the slant height. That's going to always stay the same. So that's slant height will always be 10, and that's a real key when you're dealing with this problem. So one of the things that you want to look at a little bit is I'm going to just kind of take my mouse and just think about what's happening to the radius as theta gets smaller. It's pretty easy to see on this. Now, it's a little misleading what's happening to the height on this, but you can think about this as theta gets smaller, the radius is changing. Think about whether the height's changing also or not. That's going to be a real important part of that. So that's kind of what you're looking at on that. And then on the second part of this, well, what we're looking for on the second part is, well, what's happening if angle theta gets larger and larger? Okay, now keep in mind that the slant height of 10, again, is going to stay the same. Okay, so that 10 is just going to stay where it is. So think about, if you look at my diagram on here, just think about what's happening on this. This is going to be a little misleading now when I show you this. So I'm going to take this and just kind of move this over the side here. Okay, as angle theta gets bigger, now that 10 is not changing. That's what's misleading about this. So you want to think about what's happening to H and R as theta gets bigger and bigger and bigger. Okay, like I said, it's a little bit misleading on this. So you might kind of think about what happens when those two things, when the angle gets bigger. Again, if you're not quite clear what I'm saying, it will make better sense when you get a couple of pages down in this project then. And then what you're going to look at basically on the next thing here is you're going to look at, well, what's happening to the angle? What happens when the angle changes? What happens to the volume? And again, you'll be able to see that a couple of pages down. All right, now I'm going to go to the second page of your handout, and what we'll look at is a couple of things on here. One of the things I want to look at on this second page is going to be what's happening to your angle. So let me get to this second page of the handout here, and let's kind of think about the trigonometry. This is where the trigonometry comes into play. So what I've really done on this is I've wanting you to look basically at this triangle. Okay, and notice that you have an angle theta. The slant height is going to stay 10, and the radius is going to be the value of r. So if you kind of talk out what we have, this side r is the side, that's the hypotenuse. Okay, so what we have here, or not the hypotenuse, I'm sorry, that's the side opposite right there. And then the side 10 is going to be the hypotenuse. So in relationship to that theta, you've been given the hypotenuse and the opposite. So one of the things we know is the opposite over the hypotenuse. We learned that what that is that's what the sine of theta is. So you would end up having this expression. You would have the sine of theta, by definition, is equal to the side opposite, which is given by r, and then the hypotenuse is 10. Now what you want to do is you want to take this expression now, and you want to solve it for r, and then that's going to be the correct answer that you're going to get there. It's very critical that you get that right. And then the next thing, you're going to do kind of the same thing on this. Now, I'm not going to say much on this one other than you have theta, you have a side adjacent, and then this time you have a hypotenuse. So you need to do something very similar on this problem, and then you'll get a trigonometric expression that you can find the height. I can't say anything else on that, or I'd be basically telling you how to do the problem. Now, what I'm going to say on part C is I'm giving you the volume equation. So the volume of a cone is given with this formula. It's given as 1/3 pi r to the second times h. Okay, now the value of r is going to be what you get in 2a, and then in 2b, that's what you're going to get for h. Okay, and then of course what you need to do is plug those things in. Then you need to simplify that expression. I think it's important that you simplify that as far as you can, then record that in the blank like that. Now that's real important stuff. If you don't get stuff right on this page, the rest of the project totally falls apart. So on the next page, notice that what we're really doing on this is we're changing the angles. So we're going to start with a 5-degree angle. Now in part 2a, you should have found the radius is equal to something, okay, and it has something to do with that angle. And it has to do with the trigonometric expression. The height, you found an expression for that in part 2b. So in part 2b, you should have found what the height is in relation to the angle and some trigonometric function. And then in part 2c, you can figure out the volume. So what you can do is for a 5-degree angle, you can calculate the radius, you can calculate the height, and then you can calculate, of course, the volume like that. And then you're just going to vary that from the next angle. You're going to do 20 degrees, and of course you're going to figure out the radius, you're going to figure out the height, and then you're going to figure out the volume. And you're going to go all the way down to the end, and you're going to see things changing. The radius is going to change, the height is going to change, and the volume is going to change, right? So what you're going to get into now is using your graphing calculator, and you're going to try to find the maximum volume. Now, just a couple of little hints on this. You're going to make a scatter plot for your data, so you need to kind of think about, you know, how you're going to scale that x-axis. It might be logical to just go 10, 20, 30, be sure you label everything, and you can keep that in degrees if you want to. And then the volume is going to be your y-axis, so you want to kind of figure out how you scale that. And then you're going to have some sort of a function going on here. What that function is going to be, I'm not going to tell you. You're going to find out. Okay? And what's going to say is, well, I'm asking you for a maximum volume, so that's a pretty good clue that somewhere this function is going to have some sort of a maximum. Your job is to find what value of theta that occurs at, and then find that maximum volume, okay? Then, of course, you'll just kind of write down whatever you use on the graphing calculator to figure that out, okay, your scale and so forth. Okay, so you're taking your data and you're making a scatter plot. All right, now, the next page is just going to kind of answer some questions. I'm not going to give you any hints on that. And then the next thing that we want to kind of begin to look at here a little bit is what's happening when you find the maximum volume. You're going to find the value of that angle. And then in this part 5, we're going to do something a little bit different. So I'm going to kind of give you a couple of hints on this part 5. So what you really want to do on this part 5 is you want to go through again and you want to make a table, a graph. So you're going to be looking at your angle theta for the x-axis. You're going to be looking at your volume like that. So, you know, decide how to scale your angle, you know, 10, 20, 30, whatever you want to do. And then your volume, you're going to figure out what that is. Now, it's going to go up a little higher than 300. So let's just say that in your graphing calculator, what you want to do in Y1 is you want to put that volume function in there. And you got that from question 2C. Okay, then what you're going to do is in Y2 is you're going to put in a volume of 300. So you go ahead and put 300 in there. And what you're going to end up having is you'll probably have a volume function doing something like that. You found a maximum for that volume. And then if you graph the y equals 300, see, that's basically giving you a couple of intersection points like there. So what you're looking for is what would be the angle where the volume would be 300. Maybe it just occurs at one place, maybe it occurs at two places, but you're going to use your calculator to figure that out. And on your calculator, on a graphing calculator, if you press the second button and you press the trace button, then a menu will come up. Usually it's a calc menu that comes up, and then you should see an intersect command on there, which you can use to find those intersection points right there. Okay, and that'll help you with that. And then what we kind of get into is this last thing I want you to do is you're going to take a look at the cone. You're going to kind of redo stuff that you did, but you're going to change the slant height to 40. So again, what I'm talking about by this is now you have a cone and you have basically the same things. You still have this being the height, this being the radius, this being your angle theta, but now that has been changed to 40 centimeters. So you're going to kind of redo parts of the problem to see what happens on that. Okay, so you're going to look at, again, write an equation that represents these things. This is kind of repeating what you did on like question 2A, question 2B, and question 2C. But you're repeating that, but what the difference is now is you have that slant height of 40 centimeters. Okay, so you're going to do that. And then basically to kind of summarize this, what you're going to do is you can do another graph. Okay, so you can kind of graph like you did before. And with that slant height of 40, you should be able to find a maximum volume and where that what value of theta causes that. Maybe it's a different theta, maybe it's the same theta. That's what you're going to find out. And then what you're going to kind of do is you're going to do these two things to finish up this project. So you're going to kind of look at this. So like if you had a cone and that cone had a slant height of 10 centimeters, well, okay, you figured out what its maximum volume was. Okay, you already got that. And then what you did is you just got through changing this. So if you have a 40 centimeter slant height, well, what happened to that maximum volume? Did it get bigger, and how did it relate? And you're going to find that it gets bigger, but my question is, what is the mathematical relationship between those two? There's a couple of things that are important in this. The 10 centimeters got changed to 40 centimeters, so there's a mathematical connection between those two numbers. And then the volume, the other thing that's kind of important is volume is in cubic units. So you want to kind of think about what happened to that volume. It's going to get bigger, but your job is to figure out how it changed. All right, well, that will wrap that up, and hopefully this will give you a few hints, and then you can see if you're on the right track now. Let me know if you have questions.